it is about how to represent a function as a power series. Also, if you have a power series, how to write it as a function. In fact, the main formula and the main equation that we will use in this section is this one. So we will call it equation number 1, or the convergent geometric series, because if you look at this, 1 plus x squared plus x to the power n, it is a geometric, it is a convergent geometric series with a equals to 1 and r equals to x. It will be convergent if the absolute value of r, which is the absolute value of x, is less than 1. So this is valid, ya shabab, only for x between -1 and 1. That this, the summation of x to the power n, which is 1 over 1 minus x. What is this? This is the summation a over 1 minus r. So what I want you, shabab, to just recall for so far, that 1 over 1 minus x is equals to x to the power n start from 0 to infinity. I wish that this is clear. If this is clear for you, shabab, and you understood this very well, khalas, everything next will be, inshallah, so easy. Now we will generalize this, because you know that the substitution concept in mathematics, the substitution concept says that if you have a power series that converges absolutely over this interval of convergence, then if you replace x by a continuous function f of x, then also it will be convergent absolutely, but of course for another maybe another interval of convergence. Replace x also there by f of x. Simply, it says that this is 1 over 1 minus u, where u here is in a function, it will be equals to this. So you can also look at it in a more general sense like this. For instance, let me give you an example. This is, you know this. Now, if you replace x by f of x, so this also will stay valid. Of course, f here just we want it to be continuous to guarantee that the convergence will continuous. And let's take an example. If you replace now x, this x, or this f of x by 4x squared, you will just apply this formula, but instead of x, you will write 4x squared, which can be simplified. If you want to write it, you can simplify it and write it like what? 4 to the power n, x to the power 2n. So this power series can be written as this function, and this function can be represented as this power series. But of course, not for any x, for the values of x that satisfy what? This is the function, it should be less than 1. So solve this inequality. If you solve this inequality, what you will have? You will have this. Let's solve it here. It will be 4, the absolute value of x squared less than 1. Divide by 4, this will give you the absolute value of x all squared less than 4, 1 over 4. Take the square root, you will get the absolute value of x less than half. You know that the absolute value of x squared is the square root of the absolute value. Now, we will generalize also the idea here. So let me start before starting with this, forget about this. So now, ya shabab, we have 1 over 1 minus x equals to sigma x to the power n. This is the convergent geometric series, equation number 1. Now, if it is 1 plus, not minus, what we will do? It will be what?
1 minus minus.
Indeed, 1 plus x, it is 1 minus minus. Just this plus, we will write it as double negative. Negative times negative is positive. Now, again, by the continuity substitution concept, we have here, of course, sigma n start from 0 to infinity. Instead of x, we will write negative x, this negative x, all to the power n. Now, you can write this also in a much simpler form like this, negative 1 to the power n, x to the power n. So you can, ya shabab, now please create your table. You need now to have a table for these formulas. This is the first formula. This is the second formula. This will save your time. Now you can apply it for this one now. We can talk about this now. It is the same idea. It will be 1 over 1 plus x squared. Again, it will be 1 over 1 minus Just this positive, it is double negative, equals to sigma n start from 0 to infinity for negative 1 to the power n. Negative x, you should write it as it is, negative x squared all to the power n. Then just for the sake of simplification, you can write it as negative 1 to the power n, x to the power 2n. And of course, you should if it is required, like here, he wants you to find the interval of convergence. So of course here, this will be convergent, this will be valid, this equality will be valid only if the absolute value of negative x squared is less than 1. Solve this inequality, the negative will gone, and you will have the absolute value of x all squared less than 1. Take the square root of both sides. You will have it also valid for the same values that is valid for the first one. So it is also valid for values of x between negative 1 and 1. The details, ya shabab, are here. Just replace x by negative x in equation number 1. This is equation number 1. And you will have the following. So the trick of the double negative, I think you got it now. You can now apply it whenever you need it. Now let's take another example. 1 over x plus 2. Now, how also to write this or to find a power representation for this function? What is the first thing that you should do here? Again, keep in mind this. The equation number 1, the convergent geometric series. How to go from here to here, shabab? We need to do some algebraic manipulation. Who can tell me? I advise you to write it this way, shabab. 2 plus x, not x plus 2. I think it will be easier for you to realize what you should do. Now, we need this 2, shabab. Instead of 2, this 2, we need what? We need 1. So what we will do? I wish that this is 1 and this is negative x.
Divided by 2.
We will take 2 as a common factor. Take 2 as a common factor, open brackets. So what it will be? 1 plus x over 2. It is equivalent to saying that you will divide each term by 2. The same. But you should do it for each term. So now, are we close from this formula? Yes, we have 1. This negative is not an issue because I can write it double negative, this positive. It is not an issue. So in the next step, I will write this. 1 over 2, this is 1 over 2, ya shabab. And here I have 1 over 1 minus x over 2. Now, this is equals to a half of what? What is this? Sigma negative x over 2 all to the power n, when n starts from 0 to infinity. I'm just applying this formula. Here, I replace the x by negative x over 2. Now it is done. This is the power series representation. You can, of course, simplify it in much simpler form. You can write it like what? Sigma n start from 0 to infinity. This is negative 1 to the power n. You have here a half to the power n and here half. So it will be a half to the power n plus 1. And you have here, of course, the absolute value or x to the power n. This is the power representation for this if you want to simplify it more. Now, this will be valid, shabab. You have to be careful where this is valid. Is this always correct for any x? No. This is valid only for what? For the absolute value of negative x over 2 less than 1. The condition that we have here. The absolute value of x is less than 1. This is coming from where? From the absolute value of r less than 1. From the convergence of geometric series. Now here, solve this inequality. What it will be? The absolute value of x over 2 equals less than 1. Multiply by 2, so it will be the absolute value of x less than 2. And this means that x is between 2 and negative 2. So this is the interval of convergence between negative 2 and 2. Is that clear, Shabab? Any question, please?
Yes, doctor. So there is no problem if x have a coefficient. The problem is we need 1 minus x. If it was with the coefficient or not, no problem.
Yeah, Ali, yes, yeah, Ali. If you remember in the previous slide, we said 1 minus f of x, not only a coefficient. This is equals to f of x all to the power n. N start from 0 to infinity. Do you want something more than this? just for any continuous function, not only coefficient. Whatever f, just you want it to be coefficient, and of course, the absolute value of f is less than 1.
Okay, okay.
Clear?
Clear.
Yes. Now, there is another way, Shabab. I solved this with the previous sections with another way. No one think about it, Shabab, of you?
Yes, doctor.
Yes.
2 equal
1.
1 plus 1.
Yes, yes, yes. Why you didn't think about writing 2 as 1 plus 1? طبعا it is a possible idea, but it is not good. I will show you why it is not good. Why it is not better, at least. This way is the better one. Now you can do this, ya shabab. It is as you said, it is 1 minus minus negative 1 negative x. Now you can write it like this. This will be equals to sigma and negative 1 negative x all to the power n start from 0 to infinity. What I did is just apply the equation number 1 formula. Now simplify. If you want to simplify, this will be starting from 0 to infinity, negative 1 to the power n, x plus 1 all to the power n, or 1 plus x. Now, what is the interval of convergence? What is the condition here? The condition that the absolute value of this is less than 1, which means that x plus 1 is less than 1 greater than negative 1, which means that x is less than 0 greater than negative 2. Look at the interval of convergence. What is it here and what is it here? Which one is better for you? To have more values that is convergence at, or lower values? Less or more? This one, Shabab, is better. You want this formula is valid for all x between negative 2 and 2. But this one is only valid for negative 2 and 0. So this one is better because I have more. I have the double values of x here. So this is one reason that try to get the largest possible interval of convergence. Another reason, Shabab, is this. What is the center of this series, this power series? What I mean by the series is this, Shabab, the center of the series. Here the center is A. It is about A. It is centered at A. So this series, this representation is about negative 1. The A here, A is negative 1. But here it is, of course, much easier when you have the center centered at 0. The center here is 0. So also this is another reason for that one is better. So what we conclude from this, if you have a formula like this and you need to do some manipulation, try to take a common factor. Try to write it as a power series centered at 0 as much as possible. Let's take another example. Now we have x to the power 3 over x plus 2. So there is a nice trick here, very small trick that you need to do, and it will be the same as example number 2. In example number 2, we did this. In example number 2, we did 1 over x plus 2. Now what happens here? Just we multiplied by what? By x to the power 3. So this is just x to the power 3 multiplied by this. And this is, we have it from the previous example. Here it is. Now you multiply, because this is a constant multiplied by the sigma. So you will multiply it by each term. So what you will have? You will have this multiplied by n to the power 3. Okay? What happened? Just we multiplied x to the power n by multiplied x to the power 3. So it will be x to the power n plus 3. If you don't like this to be n plus 3, you want it to be n, it's okay. What you can do? You can do re-indexing. Let me show you the re-indexing and show you the expanding method. So you can write m equals to n plus 3. In this case, when n is 0, what will be m? M will be 3. So now your series will start at 3. This is what we call, ya shabab, re-indexing. If you can, please see 11.2. So m start from 3 to infinity, of course. Now this will be what? Negative 1 to the power n. N will be, of course, what? N will be m minus 3. So this is m minus 3. Over 2 to the power n plus 1. N plus 1 will be what? Add 1, it will be m minus 2. So this is m minus 2. X to the power n. This is another way. طبعا if you expand this one or expand that one, you should have the same terms. طبعا this one, شباب, I prefer it is m minus 3. So if you know that this is the same as -1 to the power m minus 1, the same as -1 to the power m minus 5, because of course it will give you positive or negative by the same order. So you can keep it as it is, or you can keep it, write it as m minus 1. It is just about positive, negative, positive, negative. Now, since this is m, by the way, so now as I said, it is an index. You can replace m by n, and it is also the same, because when you expand it, this it will disappear. You can say m, you can say n, you can say k, whatever. It is just an index. Look here what he did. He expanded this, and this is what is the method that usually used in your textbook. Write a few terms, then try to write it in this form. If you write it this way, look what you will have. You will have that, notice what? Positive, negative, positive, negative. So this is -1 to the power n. No, it is n minus 1. And you want to start from where? From, look, n start from where? 3, 4, 5, 6. So it is start from 3 to infinity. Now here what you have? 1 over what? 2, 4, 8, 16. What is this? 2 to the power what? And here x to the power what? 3, 4, 5, so x to the power n. This is the same as we did here. Now, 2 start from where? From 3. So 3, this is 2 to the power 3 minus 1, minus 2. So it is to the power 1. And this will be, of course, 4 minus 2. So this is n minus 2, as we said before. But I believe instead of expanding and then try to guess what is the formula, it is better, ya shabab, to use the re-indexing. Again, ya shabab, in the choices, you may find this one or this one, and both are equivalent. If you expand this, you will get this. If you expand this, you will get this, the same one. It is just about re-indexing from where to start and what is the powers. Again, shabab, for the interval of convergence, it will be the same, because you know that we have found it in the previous example, because this one is in the previous example. Now, the second part of this section, shabab, is this theorem. So what has been shown before is one part, and this is the second part. In this part, this theorem says if you have a power series that is convergent, so if you have a power series that has the convergence, a radius of convergence, then this function will be defined, this power series will be equals, can be represented as a function, of course, within the interval of convergence. So then the function that is defined to be this power series in the expand form, it is differentiable and therefore continuous. You know that the differentiability implies the continuity. And you know also that the continuity, if it is continuous, it is what? It is integrable. So, and also it is differentiable, continuous, and integrable. Over where? Over the interval of convergence. Not only that, you can find the derivative. The derivative of this power series will be the usual differentiation process. What is the derivative? Let's find the derivative of this power series. The derivative will be what? What is the derivative of C0? This is a constant. There is no x, so it is 0. Plus, what is the derivative of this? The derivative of C1 times the derivative of x is 1. And the derivative, of course, of a is 0, so it is C1. Plus, this, the derivative of this will be 2, C2, x minus a all to the power 1. And you can continue doing this. Okay, here it is, Shabab. This is the derivative of this function. And you can do it directly here, term by term. We call it term by term differentiation. You can differentiate it directly here. Look, what is this? Cn is a constant. Here it is. Now the derivative of x minus a to the power n, you will write n as a coefficient here, then subtract 1, which will give you also the same one here. What you can notice here, Shabab, that we started, when we differentiate, it is not starting from 0, it starts from 1 here. Why? Why it is not starting from 0 like the original function? What happens? Why we started from 1 when we differentiate?
Because if we start from 0, it will be 0.
Yeah, Shabab, when n is 0, what is the coefficient? The Cn will be C0, and its derivative, as I showed you here, derivative here is what? Is 0, so it disappears. So in fact, the series start from 1. N start from where? From 1. Halas, there is no 0. The 0 at 0, it has been gone. Now, this is about the derivative. Now, for the integral, what is the integral of this function? It is the integral of this power series. And you know what is the integral of this power series? How to integrate? It will be, again, term by term integration. So to integrate, just you will integrate the summation, and it will be the sum of the integrals. So if you integrate it directly, look what you will have. Just you will add 1 and divide by the new power. The same power rule for integration. But again, this is in fact coming, as I said, from term by term integration. And this is only valid, of course, within the interval of convergence. So what happens here now, Shabab? This is our function. This is our function. When we integrate, let me start from here. So if you integrate this, you will have this. You will add 1 and divide by the new power. The same here. Now here, for this case, you know that when we integrate a constant, we will have C0x. But here, Shabab, for convenience, to have a power series at the same center, for convenience, we will write it x minus a. And this is not difficult. What we did just add C0a, and we subtract C0a. And this one that we added, it is combined together with the constant of integration. So it is there. Okay? So it is okay if you write it x minus a, because if a is 0, this is what is going to be. So it is just for convenience to have it all the terms centered at a. What is also good, that the radius of convergence of the power series, or of this power series and this power series, it's still as the same as the original one. It is still R. The radius of convergence, but not the interval of convergence. So to summarize, Shabab, the previous theorem, we have the following. The derivative of the summation of the power series, the derivative of power series, it is the summation of the derivative of each term. So this is term by term differentiation. So you can write it like this. N equals to 0. What is the derivative of this? It will be n Cn x minus a to the power n minus 1. I just differentiate the power. I used the power rule of differentiation. Here also you can integrate. This is a constant. And you can, of course, add 1 and divide by the new power. The power rule for integrals. That's it. Here, there is a mistake here, Shabab, for me. It should start from where? It should start from 1, not from 0 when you differentiate. Okay, the remark, as I said, Shabab, theorem 2 says that the radius of convergence remain the same, but indeed, the interval of convergence, when you integrate or differentiate, the radius will be the same, but the interval of convergence will not be the same. It may happen that the original series converge at the end point, but the differentiating one only not. This is about only the differentiation case. See example 39 for this case. Let me give you an easy way to show you that. If you have this function, Shabab, f of x equals square root of x. This one, its domain is closed 0 infinity. Is that right? So it is defined at 0. It is defined at 0. Look what will happen if we differentiate it. The derivative of this function will be what? 1 over 2 square root of x. Now, what is the domain of the derivative? It is open 0 in the infinity. It is not defined at 0. So the function was defined, this is the interval of convergence. It was here like that, but this is not, of course, at 0. So at the end point, you may lose that. More restrictions will be, Shabab, button on the domain when we have, when we differentiate. But of course, this is not the case when we integrate. If you integrate this one, you will get this one. This one that you integrate, it wasn't defined at 0, but now it is defined at 0, the new. So the integral will do the job of smoothing. It will be better when you integrate. So this is why they call sometimes the integral operator the smoothing operator. If you remember in the previous section, in example number 3, we have showed that the Bessel function of order 0 is defined for all the values of x. Now, how to differentiate it? It is so easy. You can just, to differentiate it, you can just differentiate this power series. And you know that the derivative of this power series is the sigma of the derivatives, term by term differentiation. Now, this is a constant. We are differentiating with respect to x. So this does not depend on x. It is all about n. So this is x. So what we will do, just we will keep this as it is, and we will say 2n times x to the power 2n minus 1. That's it. You can simplify, you can reindex if you want, but it's okay. Now it is time of tricks. Now the tricks, now what was before, it was direct. Now we have 1 over 1 minus x all squared. Okay, how to write it as a power series? So this is equals to sigma what as a power series. Unfortunately, he gave you a hint here. I wish that we didn't write this. Indeed, the hint is here by differentiating the equation. Now again, Shabab, when you have any question, you should just try to relate it to this, because this is all what we have. How to relate this to this? If you look, what is the derivative? What is the derivative of 1 over 1 minus x? Check that. It is this one. Why? Because it will be 1 minus x all squared. Here you will have the denominator multiplied by the derivative of the denominator, which is 0, minus the numerator, which is 1, multiplied by the derivative of the denominator, which is negative 1. So this will be negative times negative is positive, and it will be 1. So what we can say, that this one that is given for me, it is just the derivative of this one. And what is this? What is 1 over 1 minus x? It is sigma x to the power n from 0 to infinity. And you know how to differentiate this. You know the derivative. It is term by term differentiation. It will be equals to what? The summation of the derivatives. Now, when we differentiate, it will be what? N x to the power n minus 1. N starts from where, Shabab? From 1 to infinity, because the first term will disappear. Now, this is this power series is equals to this one. And of course, he asked for the radius of convergence. We use this representation. So for this representation, the condition is this less than 1. So it is still the same condition, the same condition. So R here is 1. This is the radius of convergence. And the interval of convergence is negative 1 and 1. Again, Shabab, you can re-index this, by the way, if you want. Look what he did. طبعا, you know that this is the expansion. This is equation number 1. Now, if you differentiate this, you will get this. If you differentiate this, you will get this. And this is, of course, the formula that I told you about. You can re-index it by the same way that I told you, Shabab. How to re-index this? This is starting from 1. If you want to start from 0, just replace n by minus 1 by n, or in a simpler way, put m equals to n minus 1. Now, when n is 1, m will be 0. So we will start from, let me write m instead of n. It's okay. It is m, and this will be m. And this is n. N is what from here? N will be what? Move 1 to the other side, m plus 1. So this is m plus 1. It's okay. You can write it n or m. It doesn't matter, because it is an index at the end. Return it to n. So it is about re-indexing. You can obtain it also from the formula there. The radius of convergence is the same. Let's take now another trick. Len 1 plus x. This is equals to what as a power series? This is the question now. How
integral of 1 over x.
Representation. Yeah, Shabab, do you notice that he said find a power representation? Because there are many. It is not unique. If it is unique, he will say that. So it is about finding one of the power representations for this. So what is now? Keep in mind that all what we have so far is this. And also when it is plus, you have here negative 1 to the power n. So what is the relationship between this and this? How to relate this to what you have known before?
This is the integral of that.
Yes, len is the integral. Len 1 plus x, it is the integral of 1 plus x. And you know what is this? We have shown this before. This is just negative 1 to the power n, x to the power n, the integral. And you know how to integrate this. It will be equals to what? Negative 1 to the power n. You will integrate x to the power n plus 1 over n plus 1 by the term by term integration. And this is the sigma. N start from 0, it's still from 0 because the integration will not, we will not lose any term. Indeed, we will have another term, which is the constant. So this is what we have. Now you can, of course, ya shabab, expand it. You can write a few terms at the beginning to see how it looks like. Of course, you can find also the constant. What is the constant? If you put x equals to 0, what you will have? You'll have ln 1 plus 0, which is ln 1, which is 0, equals to, when x is 0 here, what is the first term, ya shabab? The first term when n is 0 will be x. So it will be 0. When x is 0, all of this will be 0 plus c. And this means that c is 0. So no need for c. You can omit it. I think your book, again, he's focusing on expanding. Look, you know what is this? It is the sigma that I told you about. We did this before. Now expand or integrate term by term. There is a mistake, Shabab, in this slide, I think. Here, it should be this one here written. And of course, now integrate. The integral of 1 is x. The integral of this is this, term by term. And of course, now put x equal to 0 to find the integration representation. Again, there is reindexing. I told you that we have it before, like n started from 0 to infinity for negative 1 to the power n, x to the power n plus 1 over n plus 1. Is that right, what I said? Yes. It was like this. So now it is just, it equals to this one as a matter of reindexing. Again, both n plus 1 equals to m, and do the indexing that I told you about. When n is 0, you will start from 1. So in the choices, ya shabab, when you have a multiple choice, you may find this in the options or this, and they are equivalent, or this, and they are both are equivalent. So now, ya shabab, you can update your table, please. The table that I told you to make for formulas, you have a formula for ln 1 plus x. It saves your time if you can recall it. We will focus more on that in the next section 11.10. The same idea, find a power series representation for tan inverse. Tan inverse is what, ya shabab? Who can tell me? It is what? It is the derivative of what, or the integral of what?
1 over 1 plus x squared.
1 over 1 plus x squared.
Derivative or integral? Tan inverse equals what?
Integral of 1 over 1 plus x.
Integral, yes. Tan inverse is the integral of 1 plus 1 over x squared. And we have found the series representation for this one in example number 1, if you remember. So we did that in example number 1. Here it is. Just we applied 1 over 1 minus x squared, and we applied the equation number 1. Again, ya shabab, you can do this immediately like this. Integrate term by term. This will be negative 1 to the power n. It is not about this, it is about x. X to the power 2n plus 1 over 2n plus 1. That's it. So this is what is tan inverse equals to. And again, I want you to add this to your table of formulas. So tan inverse x can be represented as a power series like this. If you have this, you can write it as tan inverse. طبعا, if you want to expand, ya shabab, you can do as I have noticed in your textbook, they like to expand this. Now you have here even powers. When you integrate, this will be what? X to the power 3 over 3, and so on. Look, this is what you have. Plus the constant of the integral, the integration constant. Now, how to represent this as a power series? You will do the same as I did. Yani. This is, of course, 1, 3, 5, 7. So it is 2n plus 1. And the constant, again, you can find it by the same way. When x is 0, tan inverse of 0 is 0. So this will be 0, 0, 0, 0, and you have c. C is 0. No need. You can cancel the constant. Now we can say that tan inverse x is what? X minus x to the power 3 over 3 plus x to the power 5 over 5 minus x to the power 7 over 7, which can be written using the sigma notation like this. And what is, ya shabab, here good about the beauty of mathematics or the consistency of mathematics? You know that tan inverse is odd function. Do you remember that? It is odd. And look
Yeah.
at the powers that we have here as a representation for tan inverse. All of them are odd. And you can see that also for sine and cosine. For sine, you have odd powers. For cosine, you have even powers. So this is the representation, Shabab. And of course, the radius of convergence, we use this, which has the same convergence radius. Let's take one last example before we start practicing. This is one of the main objectives of studying power series. How to evaluate this integral? You cannot do this, ya shabab, with the ideas of chapter 7. I remember that some of you, they give me many questions that cannot be solved with the ideas of chapter 11. We will see some of them, of course, in 11.10. Many examples will be shown there. One of them is this one. You cannot use any method that you have studied in chapter 11. But of course, you can at least approximate this as a power series. So you may have an idea about how it looks like. So what you will do, you will try to find the power series representation for this. By the same way, the plus here, it is double negative. And here we have the formula, we will apply it. Then what you will do, you will simplify, then integrate. When you integrate this, just you will add 1 and divide with the new power, plus the constant of the integral. Of course, this is an indefinite integral. We don't know, so we will keep the constant there. So this is the solution. When you have it, especially when you have it as a definite, let's say, for example, from 0 to 1, you can approximate this, approximately what it will be. So this is, of course, not valid always. It is valid only for x between -1 and 1. It will be exactly here, outside this interval, it is approximation. But for this interval, it is exactly equals to this infinite power series. This is all what we have, ya shabab, in 11.9. Let's summarize. What we have in 11.9, Shabab, we have two main ideas. The first idea is this, 1 minus f of x for any continuous f of x equals to sigma f of x all to the power n, provided that the absolute value of f of x is less than 1. This is the first idea. The second idea is how to do the integration and differentiation term by term for power series, as we shown in the previous theorem. Now it is time to practice. I will leave these for you, Shabab, because they are solved completely, and we will solve some old exams that they are not solved, like this one. I will give you, Shabab, 2 minutes or even 3 minutes, no problem, to solve this. Please take a pen, ya Shabab, and paper, and start to practice by solving this old exam question. It is good, ya Shabab, to test yourself. It is easy question. It is very easy. Just to see, did you get the ideas or you need to work more? Please, I will give you 2 to 3 minutes to solve it. And I already launched a polling for you, so you can choose what is the right answer. Okay, Shabab, the time is up. If you have an answer, please choose now because I will end the polling. So we have like 26 students out of 38. Good number, not bad. Let me share with you the results. We have even between A and E. MashaAllah, you have distributed your answers over all the options. Unfortunately, Shabab, only 8 students, they got the right answer. The answer is A. The right answer is A. Now, why it is A? Is anyone, Shabab, who from the students who said A, please can you share with us your idea? What you
Yes,
did?
doctor.
Yes, Ali Tuwailib, Ali, what you did?
First, I x multiplied by 1 over 1 minus 2x squared.
So this will be equals to x multiplied by 1 over 1 plus 2x squared. I prefer, Shabab, to write it like that because you need to remember that this is what you have. Just always, when you have question like this, write this down and you will be able to realize what you should do. Thank you, Ali. So next, what you will do, as Ali said, we will say x times 1 over 1 minus 2x squared. Is that what you said, Ali?
Yes.
This is x multiplied by what? Now this is equals to what? This one.
The sigma.
N starts from where?
Equals 0.
To infinity?
Infinity. Minus 2x squared to the power n.
Exactly. And this is equals to, if you want to
Minus
simplify,
2. Yeah.
negative 2 to the power n, x to the power 2n. Then
yeah, and the x outside, it's going to be x to the power n, 2n plus 1.
Each term by x, so it will be negative 2 to the power n, x to the power 2n plus 1. Because you know that x to the power 2n multiplied by x, it is x to the power 2n plus 1. And it is clearly option number A. So easy. I don't know what is the problem with you guys. Please. Okay, let's have another one. Any question about this? You may have it in different ways if they can re-index it for you, but clearly here it is all about n starting from 0, so there is not any trick, re-indexing trick. Yes, يا محمد.
يعني دكتور الاكس اللي يكون في البسط نعامله كانه كونستانت منه في هالنوع من الاسئله.
احنا الفورمولا اللي عندنا هاي اللي عندنا الان عندنا 1 minus x.
صحيح.
فانا كيف استخدم هاي؟ عشان استخدم هاي احاول الفانكشن اللي عندي اكتبها بهذا الشكل. هذا الاكس it is the same x as here, but I will work on this one as a power series and then I will do. We did this trick in the examples before. So this is all about finding this or writing this in the standard form to have it written in this way. 1 minus u times u to the power n. U in this.
Okay.
So now again, Shabab, I will give you 2 to 3 minutes to solve this one. Let me launch polling for you, relaunch it. Please take a pen and paper and start a real practice. If you can solve this question, you have to be satisfied about yourself and you mastered the subject of this section. It means you understand the tricks, all the tricks that we had here, re-indexing, differentiation and integration, the power, the geometric convergent geometric series formula, equation number 1, and the continuity concept, also the substitution concept. I prefer to put this at the end because if you can solve it, معناته ما شاء الله, you have controlled and mastered the subject of section 11.9. For those students who choose already an answer, they are kidding, I'm sure. Or they are just bought it as a guess. I don't believe that we have superheroes that they can solve this question in 1 minute like that. For example, who chose so far, ya shabab? Who can tell me what he did? We have 3 students voted so far. Please, any one of you can speak up and tell me what he did? Ya shabab, you have to be serious, please. We are not here, it is not a game. We are not here to play. Practice, real practice. It is not about choosing any answer of salam. No, it is not about that. This is not our target here. If you are in the exam, do whatever you want. But when we practice, we need a real practice. There are many tricks in this question. It's not difficult, by the way, if you got the idea of relating the differentiation to the formula that we have. You may also use re-indexing. I don't know, I didn't use it. We still have only 2 minutes, ya shabab, to the end. This is the last minute, ya shabab. Let me end the polling and show you the right answer. Okay, the right answer is C, not A, as many of you say. We have 5 students with option C. Any one of you, ya shabab, can speak up and tell us what he did to obtain C? To obtain the right answer, what he did? Anyone from the 5 students who choose C? Okay, that's it. We will see that tomorrow, inshallah. We will solve it tomorrow. So think about it until tomorrow, shabab. Think about solving this exercise for tomorrow, please. See you tomorrow, shabab.